Hi folks, it's me again. We're going to look at chapter 4 now. It's going to be all about trigonometry and the unit circle. We did a little bit of the unit circle in the grade 11 course, just to introduce to you a few things, like the special angled triangles, if you recall that. If you recall the special angled triangles and can kind of recapture some of that information back, it'll come in handy in this section and the next one as well. We're going to cover these 4 outcomes, and this is hopefully what we're going to get to do. All right, now in the first one we're going to look at angles and angle measure. Now, an angle in standard position has its center at the origins, that's right here, and its initial arm along the positive x-axis. This right here is the initial arm, okay? It's sitting right on the axis, so you really can't see it unless we make the line thick. Now, our angle starts here, and then it goes up all the way to the terminal arm. The terminal arm is where our angle terminates or ends. And then this is our theta. So that's our angle measure, theta, that's right there. Now, we're going to look at angles terminating in all of the 4 quadrants, but first we're just defining that our angle in standard position is right here. Okay, now just to recall, this is going to be quadrant 1, this here is quadrant 2, this over here is quadrant 3, and this is quadrant 4 down here. Now we're going to talk about positive angles and negative angles. Positive angles go counterclockwise, so that's the opposite direction that a clock goes in. And if we were to draw the terminal arm right along here, this angle measure would be approximately 250 degrees, let's say. Okay, because this is from 0, this is 0, this is to 90, this is to 180, and then this is just past, and it's not quite all the way to 270. There's probably about 20 degrees here we can estimate. This angle measure is exactly the same as this one, except for where it starts and ends. This angle goes in the negative direction, and it starts from here and goes all the way around here. So if we were to draw the terminal arm right here, we could say that this angle measure here is negative 250 degrees. Okay. So which quadrant is 400 degrees in? So we're going to assume that we're going in the positive direction. So we're starting here and we're going around this way. Now, 400 degrees is going to go all the way around 360 and then a little more and end up in the first quadrant. Negative 65 is going to be starting here, and then it's going to go in the negative direction. It's not going to make it all the way to the, this from here to here would be 90, so it's not going to go any further than that. This is going to be in quadrant 4. Okay, 700 degrees is, well, 1 full rotation is 360, and then and 2 full rotations would be 720. But it doesn't go all the way. It goes kind of like up to there. So it ends up in quadrant 4. And negative 150 degrees, well, this one is going to go in the negative direction. So it's going to go like that and probably end 30 short from this line. So we'll say around here, and that ends up in quadrant 3. Okay, on the next page, you're going to see an activity that describes what a radian is. It introduces you to the idea. We're going to do this one in class. If you miss class and you want to do it yourself, you can just follow the directions and ask any questions if you have any. All right, now what this is doing is it's relating what a radian is to a circle. Okay. All right. Now we know this formula from very long time ago, that the circumference of any circle is 2 pi r. The unit circle has a radius of 1, so that's a unit. So we're measuring the length of 1 for the unit circle. If I were to figure out the circumference of a circle with radius 1, then my circumference is going to be 2 pi, or if we want to estimate the number, it would be somewhere around 6.283185, and I don't know how many numbers of pi you know, but you would just double it and go from there. So this means that the distance traveled from the initial arm all around the circle and back again is 6.283185. So that's from here and all the way here. All right. So let's look at 1 revolution, which is all the way around. That is 360 degrees. This is equivalent to 2 pi radians. This is just a different unit to measure angles. Now, the radian measure, that's what it would be in decimal form, in an actual number. The decimals keep going forever, so we don't really like to use this notation. We prefer to use this here. Now, half a revolution would be from here up to here. So that's 180 degrees. We know that. And that's going to be 1 pi radians. And hey, look, see, this is the actual value of what pi is. A quarter revolution is going to be from here to here. That's 90 degrees. And that's the same as pi over 2. And 1 degree, so if we go 1/360th revolutions, so if we divide this whole circle up into 360 sections and only go one of them, then that is what 1 degree is representative of. So this is the same as pi over 180. Okay, and that's the decimal form of it. So I want you to make note that 1 radian is equal to 180 over pi degrees. And that is approximately 57.3 degrees. So 1 radian, that's a unit measure, that's a measurement, is approximately equal to 57.3 degrees. So we're going to be talking about radians now. We're going to be doing some conversions from radians to degrees and degrees to radians. And I just wanted to make note that since 1 pi radians is equal to 180 degrees, which is from here all the way to here, it's half a circle, we can set up these ratios, pi over 180 degrees or 180 degrees over pi radians.